Good morning everyone. Now I am going to take the class for Basics of Electrical and Electronics Engineering. The module 1 consists of properties of a material. Why we have to study the properties of a material? As a fashion and textile technology, you have to know how the material behaves when it is exposed to electricity. So first of all, we will study what do you mean by material? A material is a thing which constitutes an object. Material is used for making an object or a man-made structures. That is, if we say if it is a steel or something else which is used to construct a building, so we will call that as a, in terms of engineering, we will call engineering materials, which is for man-made structures, material which helps to form man-made structures. So we need to know how the material behaves when we are molding it, heating, when we pass a light, how it reflects. So we need to know the properties of a materials. So there are different properties of a materials are available. The main things are listed out here. The first is the optical property, the nature of light, how it behaves. The next is the magnetic property. When we expose the material to a magnetic field, how the property varies, how the material behaves. So exposure to magnetic field. Then mechanical property. When you apply a mechanical stress or other forces, how the material behaves. That is called that property will come under mechanical property. Next, thermal. When you apply a strong heat, the material conducts heat, or it is a repellent or resistivity to temperature, high temperature. So that will be considered for thermal property. If we know the thermal property, then only the material will be of the quality of the material can be known. If we want to use it in a temperature resistance medium, we need to know the thermal property. The next is the physical. When you apply a stress, how does a material deforms? Elasticity, it regains its own shape. So we have to see the physical properties also for a material. For plastic and all, if you heat, it will get melt. Then for molding a plastic, they will apply a certain limit of temperature. So we have to note the temperature changes also. The next, chemical property. The chemical composition varies. Change in composition. So we need to consider the chemical properties. So as a BEEE paper, we will be studying only the electrical properties of a material. The electrical property of a material is the sense we will be studying voltage, current, everything. Simply electricity means we will say current and voltage. But beyond that, we have certain properties which a material can have. The first thing is this: resistivity, conductivity, and capacitance. The resistivity of a material, conductivity of a material, capacitance of a material, if this varies, if this is present in a material, then the total nature of the material gets changes. So we need to test the quality of the material in terms of electrical. So before going to these topics, we will be seeing what is the basic fundamentals of electrical engineering. The fundamental things. First you will say the first thing is this: electrons. Electrons will flow, charges will flow. The electron is nothing but a negative charge present in an atom. So if it is an atom is having a valence bands, different number of bands, the last band is the valence band. Here electrons will be revolving. These last band electron is called as free electrons. These electrons will flow when you apply an external force. So these electrons moves in a medium. So this is called, this electron is called as negative charge flowing. If the If the structure, the conducting material is like this, if the charge or the electron moves, then this flow of electron is called as current. The current is called flow of electrons or negative charges. Then what do you mean by voltage? Voltage is nothing but a potential difference, they will say. First of all, we can say what is a potential difference? Simply potential difference between 2 points. But the thing is that here, if you give a supply or give an external force, the density of electron at this point and the density of electron at this point, the difference between these 2 points is called as voltage. So let us assume this is V2, this is V1. So V2 minus V1 is called as voltage. The unit of electrons or electric charge is coulomb or C, we will say. The next unit is ampere or amps. Voltage is volts or we will say V. Then next comes the resistance. The resistance is the thing which the ability of a material to oppose the flow of charges. It is an ability of material to oppose the charges. If you are having a tank, a pipe is flowing like this, there is a valve and here is a open. See, when this valve is opened, when you open the valve, the water will be flowing in much pressure. So when you apply a resistance, that is when you close, this valve will close. This valve acts as a resistance here. That is, it blocks the flow of water. Similarly, the resistance also blocks the flow of current or electric charges. The next, inductance. It is the ability of the material to store charges in an electromagnetic field. It stores charges in electromagnetic field. Simply we will say inductor is a magnetic coil, electromagnetic coil. Let us example, we will say copper coil. When you give a supply to a coil, what happens is that it gets the electrons while flowing through it, it generates a magnetic field. Magnetic field also gets generated in this coil. So it also acts as a so therefore electric field is also flowing, magnetic field is also flowing, so electromagnetic field will be generated. When this happens, EMF will be, some opposing voltage will be produced inside the coil. So that coil, that is the means of storage of charge. That is when the inductor stores the charge in the form of electromagnetic field. Its unit is Henry. Next, capacitance. Capacitance is its ability to store, ability of a material to store charge in electrostatic field. It stores charge in the form of electrostatic field. Similarly, when you apply a voltage, when you apply or supply a voltage to the conducting plates, what happens is that it generates charges, positive charges on the one side of the plate, and also generates because of this positive charges accumulates on one side of the plate, negative charges will be generated on the other side of the plate. So this is it is a static field, stationary field. By applying giving an electric field, we are creating a charges accumulating on the plate, that is called a static field. As we have seen the basic properties of the basic fundamental properties of the materials, we are going to start the what are all the major properties. Conductivity, we will say. First of all, what do you mean by a conductivity? Conductivity is the property of a material that it is capability of a material to allow how much amount of electric charge flowing through it. That is simply in the sense, conductivity sense, the amount of electric charge, it is a capable of a material to allow the electric charge to flow through it. Every material may allow the charge to flow in the sense, if it is a conductivity material, it has the property of conductivity. A material act as a conductor. We will say conductor, semiconductor and insulators. That is based on the conductivity nature of the material. We classify those things as conductor, insulator and semiconductor. But first of all, the conductivity is the sense, it is the ability of a material to allow how much amount of current to passing through it. So next, as I said, based on the conducting nature of the material, the materials are classified as three types. We will say conductor, insulator and semiconductor. First of all, conductor. Conductor is the thing which allows current to flow through it. Allows current to flow through. Insulator. Insulator restricts current. It does not conduct any charges through it. Semiconductor is the sense, it is somewhere in between conductor and insulator. Sometimes it conducts. Therefore, we say semiconductor is partially conducting material. Why this thing is happening is that the conductor has a energy. We will draw the energy band diagram for conductor. There will be, as I said, bands, valence band and conduction band. This will be overlapping in conductor. Electrons will be present. Holes will be present in the conductor. When you apply a voltage, what happens? This electron will move to the conduction band. So, these repetitive holes in conduction takes place when you apply a voltage. So, valence band and conduction band. This is valence band. As I said, for a conductor, the valence band and conduction band is overlapping. But for insulator, there will be a huge band gap. We will say sometimes this is infinity. The band gap is infinity. Even when you apply a voltage, electron transitions will never happen. But also we can say that the conductors will have free electrons on its surface. It has free electrons on its surface. But this insulator does not have any free electrons. So there will be no free electrons in the valence band. That is 0. Electrons in the valence band is 0. Then here comes the semiconductor. The semiconducting nature of a material somewhere between valence band and somewhere between conductor and insulator, as I said, the band gap will be of minimum. So when a certain temperature or when a certain breakdown occurs, this electron will replace the hole in the conduction band. Will replace the hole in the conduction band, as I said. If you apply a voltage, when a certain breakdown occurs, this electron will flow to the conduction band. So we call this as a semiconductor. These are the difference between the conductor, insulator and semiconductor. Now, the next property is the resistivity of a material. Resistivity in a sense, it is the ability of the material to restrict flow of charge, flow of electric charge in it, and it is denoted by ohm meter. Sorry, its unit is ohm meter and it is denoted by rho equal to RA by L, where R is the resistance of the material, amount of electric current which is restricted, that is called resistance. Then A is the area of cross section and L is the length of the material. So there are, if we take a material, we can measure the material's resistivity in three forms. One is surface resistivity, another one is bulk resistivity and contact resistivity. The surface resistivity in the sense, the resistance of the material with its length, that is on length, not area, into area. That is, in the sense, we are calculating the resistivity on the surface, how surface area around the material. On the surface of the material, if we calculate the resistivity, then it is called as surface resistivity. Bulk or volume, that is inside the material. So we need to calculate the resistance with the volume. So the volume in the sense, it will be having with thickness by length. Then contact resistivity, this is not a sense of measuring the resistivity, but it is the thing which checks the quality of the electrical connection we have given to the material. So simply we are saying that this formula will be used for calculating this resistivity, everything, but how we will measure the resistivity of a material. Now let us take a sample circuit diagram. This helps to make a how we will measure the resistivity of a material. This measure of resistance of a material, this I have given for a fiber material. So I have taken a single phase transformer which is reducing the amount of 230 volt to 12 volt AC. So we can't give the material directly at AC supply. If I give as I have said, I am giving a fiber material. Let us take this as a jute or a cotton. If I apply a 230 volt to the fiber material, what happens? The fiber material will burn because it is a very thin material. So we have to convert that into a DC volt. So for that I am using a rectifier bridge circuit. So this converts AC to DC. Here 12 volt DC supply will be going through this resistance. This resistance is for knowing how much amount of voltage is going through this and to the resistance. This we will consider as a small value, amount of negligible value. So if we supply to this with the help of Ohm's law, V equal to IR, we can calculate the resistance, how much amount of by keeping a voltmeter, by keeping a ammeter and voltmeter, we can measure the resistance of the material. Through this resistance, if we know the surface area of the material and length of the material, we can calculate the resistivity of the material with the help of RA by L. This method is called as two probe method. But one thing, the two probe method has a drawback is that this involves the circuit conductor wires will have some resistance property. So that resistance will also get included in this. The two probe method has a drawback that the two probe method has a drawback that it will include the resistivity in the conducting wires also. That resistance will also get included in this. So we have to neglect that resistance also. For this, we will prefer 4 probe method of resistivity measurement. Thank you.